Dear students, welcome to the video lecture of for loop. The for loop. A for loop is a repetition control structure that allows you to efficiently write a loop that needs to execute a specific number of times. A set of statement will get executed in a specific number of times. The syntax of a for loop in a C programming language is given below. For the open and close parentheses. So you have to give a initialization, semicolon, condition, semicolon, increment within the open and close curly braces. You have to give a set of statement. So initialization, which initializes the loop variable, that this will be executed only once. Following that condition is checked. If the condition is true, the set of statement in the for loop will get executed. After that, this is an increment or decrement portion of the loop variable. Okay, so increment or decrement will happen. Then condition is checked. Then set of statement will get executed. Then increment or decrement will happen, and condition and set of statement. Until the condition is true, the set of statement will get executed. We can say that first condition is true, the set of statement will executed. After this, the increment or decrement will happen. Again, condition is checked. It is true. Set of statement will be get executed. Then the increment or decrement will be checked. Once the condition is false, the control will jump to the next statement after the for loop. That means the after the statement followed by the close curly braces. The init step is executed first. The init step is executed first only once. The step allows you to declare and initialize the any loop control variables. You are not required to put a statement here as long as the semicolon appears. This is optional. For example, init, okay, you are initializing the loop control variable. You are initializing in the before that, just put a semicolon, that is sufficient. Okay, if you initialize the loop variable before the loop, it is also possible. Okay. Then second is a condition is evaluated. If it is true, the body of the loop is executed. If it is false, the body of the loop does not execute and flow of control jumps to the next statement just after the for loop. Okay. If this condition is true, what will happen? The control will execute the set of statement into the body of the loop. Okay. This is it's a loop header. The open and close curly braces which contain the body of the loop. Okay, and a condition is false, the control flow jump to the next statement after the for loop. After the body of the loop executes, the flow of control jumps back to the increment or decrement statement. Once the body of the statement get executed, the flow control jumps back to the increment or decrement. The statement allows you to update any loop control variables. The statement can be left blank as long as semicolon appears after the condition. For example, it's optional one. If you increment a loop variable inside the body of the loop, then you have to put a, okay, there is no need to give anything. A semicolon after the condition is sufficient. So in it is possible, it is optional. We are able to initialize before the loop begins. It will execute only once. If we are initialized before the for loop, only semicolon is sufficient, followed by condition and increment decrement. If you done it inside the body of the loop, there is no need to give in that place. Okay, it can be left blank. Okay, but semicolon should be there. Okay, semicolon followed by condition and semicolon should be there. Okay, should not, okay, we should not give a semicolon in within the after the header of the for loop. That means the loop will get terminated, the body will not get executed. This is a quite common mistake the freshers is used to do, so that should be avoided. The condition is now evaluated again. Okay, once the increment, after the increment or decrement, the condition is now evaluated again. If it is true, the loop executes. The process of the process repeat itself. The body of the loop, then increment step or decrement, and then again condition. Okay, this will go repeatedly. After the condition become false, the for loop terminates. Once the condition become false, the for loop terminates. So first we have first program. We are going to, okay, we'll see the flow diagram of the for loop. Okay, first initialize the condition. It's the beginning. Initialize the condition. Check the condition. If the condition is true, the body of the loop will get executed. That is a code block. Okay, then increment decrement will happen. Again, to check the condition. If the condition is true, the code block will get executed, and increment decrement will happen. Again, check the condition. Once the condition is false, okay, the statement will go to the control will go to the next statement after the for loop. So we'll see a given number is a simple program for the a given number is a prime or not. Okay, we'll discuss in the code blocks. A given number is a prime or not our program. So what is the prime number? First, a number which is divided by itself okay, and 1 as a remainder is 0. For example, if you take, okay, 5 is a prime number, because when the remainder is 0, when 5 divided by 5 1, or 5 divided by 5, okay, the remainder becomes 0. Okay, otherwise what will happen, it will have any value. So a number, okay, which divided, okay, when return is remainder 0, when divided by itself and divided by 1 is known as a prime number. We have to find a given number is a prime number or not is our program. Okay, a given number is a prime number or not is our program. So you have to check. So 5 is a prime number. If you take a 6, okay, 6 by 3 equal to 0. As like a 6 by 2 also, remainder is 0. So what will happen? Okay, so such a kind of numbers are not a non-prime number. We can say that it's a non-prime number. If you take a 7, 7 is a prime number. 9 is not a prime number, because 9 will, okay, when divided 9 by 3, what will happen? Okay, 9 will return a remainder as a 0. So this is known as a prime number. So we will have a program for the prime number. So this is a program. Void main. I'm declaring a 3 integer variable, integer n, I, and flag. Okay, so print of enter a number. I ask the user to enter a number. Scan of percentage d ampersand n. The number is stored in the variable n, in the memory address of the variable n, entered number by the user. I am declaring a flag variable, flag equal to 1. So what will happen? I'm running a loop. It starts from for I equal to 2. Okay, the loop is initialized with I equal to 2. As we discussed that the loop will get initialized only once. The loop will get initialized only once. Okay, if I less than n, okay, n is a number entered by the user. I less than n. Okay, I plus plus. Where the loop will go? For example, if we enter 6, the loop will go from 2 to 5. Okay, 2 to, okay, I less than n means, okay, that means the loop will go up to the value n minus 1. So I'm having a if condition, if n modulo I, modulo return a remainder. Okay, so what will happen? We'll check an example. For example, I'm taking a value, okay, I'm taking a value 5. Okay, what will happen? I equal to 2, I will check the n modulo I. N modulo I will return a remainder. Okay, what is the remainder? Remainder is 1. So that means that, okay, it's not a 0. Again, it will go to next, okay, it will go to I plus plus. I is become 3 now. Then I check 5 modulo 3. Okay, what is the remainder? Remainder is 2. Okay, then it will not go to F loop. Then I is become, okay, I is become 3 now. Okay, 5 modulo 3 is, I mean, I is become 4 now, I plus plus. Okay, 4 less than, okay, what is my n value? N value is 5. 4 less than 5. Now what it do? 5 check 5 modulo 4. So what will happen? It will return a remainder 1. So I plus plus, what will happen? Now I is become 5, 5 less than 5 equal to false. It will come out of the loop, it check the value of flag. So what is the value of flag? The flag value is 1. It is a flag value. If you print of percentage d is a prime number, percentage n. Okay, for example, print the 5 is a prime number. Okay, for example, I'm giving a 6. What will happen? I'm giving a value 6 now. What will happen now? Okay, we'll discuss the program. I'm giving a value 6. Okay, we'll check 65. What will happen? So for example, n, I am giving it as a, okay, 6. Okay, what will happen? So here I'm flag equal to 1. I'm initializing I equal to 2. Okay, so I equal to 2. So what will happen? I'm checking here and 2 less than, okay, 6. Okay, this is also correct. Okay, I'm checking n modulo I. That means n is 6, modulo I value is 2. What is the remainder? Remainder is 0. In this case, what will happen? If you go and set the flag equal to 0. So flag value is 0 now. And break. So break means if your control will come out of the for loop and come to this place. Okay. Out of next statement after the for loop. We check the flag equal to 1 means no. Then in else part, if we go print out percentage. Okay, what it will do? Flag equal to, okay, if we check flag equal to not a 1. Okay, flag equal to 0 now. Okay, if we go to else part and print percentage d is not a prime number. Okay, percentage d will take the value of 6. Okay, if you print 6 is a non-prime number. So this is the output for this program. Okay, we will run the program and check what will happen. We set the value flag equal to 1. Whenever the n value n modulo I is become 0, it will go to inside the if block. If once goes inside the if block, that means what it means? It's not a prime number, because I will go from 2 to n minus 1. Okay, if between that it is divided by a number, okay, which return remainder is 0. That means that what will happen? Actually, that is not a prime number. We can say that this is a non-prime number. So in this case, okay, the flag is become 0 and under break. If you come and check the flag equal to 1, and it return the go to else part and print the given value is not a prime number. If it is a prime number means what will happen from 2 to n minus 1, it will not go to this inside the if block. Okay, so what will happen, the value of flag cannot be changed to 0, it will remain as a 1. So on the time, okay, it will divided by 2 into 2 to n minus 1, the remainder is not a 0. In this case, the flag value is the old, it in the old value, it come out, okay, after the condition is false, it will come out, check flag equal to 1, percentage is as a print a prime number. Okay, from 2 to n minus 1, in the division, the n does not return a 0. That means that, okay, the flag value remain 1. Okay, that is a prime number. Otherwise, if it return a 0, for example, 2 to n minus 1, if it return a value, if divided by any value, return a remainder 0, then it is not a prime number. That is the logic of this program. We'll run and check the program. Okay, I'm entering 5. So it will return 5 is a prime number. So I'm entering a value 5. So here it returns a 5 is a prime number. Okay, I will check. I'm giving another output. For example, I'm giving another output. For example, this is 6. 6 is a prime number. Why it is a prime number? Okay, 2 will divide and 3 also divide. Okay, it will divide and as a remainder become a 0. Okay, when you divide it by 6 by 2 and 6 by 3, remainder is become a 0. So it is not a prime number. For example, I will check 11. What will happen? Okay, I'm giving a number 11. So 11 is a prime number. Okay, 11. When you divide 11 by 1 and 11 by 11, then only we'll get a remainder 0. That's why 11 is a prime number. Okay, then we will check 15. Okay, 15. 15 is a non-prime number. Why it is a non-prime number? Okay, 5 will divide 15 by remainder 0. 3 will divide 15 by remainder 0. That's why the 15 is not a prime number. Okay, our program logic is working very correctly. We are going to discuss about the another program. Okay, this is a program we discussed so far. Okay, print a multiplication table. This is a multiplication table of our, okay, example. What it will do, if you enter an integer, for example, any integer, it will give the multiplication table from 1 to 10 of that integer. For example, if you enter 5, it will give a multiplication table of, okay, 1 to, okay, multiplication type from from 1 to 10. For example, if you print 5 star 1 equal to 5 up to what will happen? Up to it will go to 5 star 10 equal to 50. Okay, it will go all the way 5 into 1, 5 into 2, 5 into 3, 5 into 4, like this, it will give a multiplication table. Okay, so what is the logic behind this? I'm declaring a two integer variable, that is n and I. I'm printing, I am asking the user by printf statement, enter an integer. The entered integer is stored in the, okay, variable n. Percentage d is a format specifier of the integer. Ampersand n, okay, the entered value is stored in the memory address of the variable n. N is the integer variable, that's why format specifier percentage d is given here. I'm writing a loop for I equal to 1, I less than or equal to 10, I plus plus. Okay, I equal to 1, what it will do, it will print percentage d into percentage d equal to percentage d. Okay, these are all the string. If you print percentage, you take the first integer value, that is n. So what is n? For example, if I give a n 5 means, okay, 5. What will happen? Then if you print a star, okay, after that percentage, it will take the I value. So what is the value of I? I starts from 1, okay, 5 into 1, and it will print a equal to percentage d. It will take the third n star expression value of n star I equal to 5. Then what will happen? I is become 2 now. Okay, it will come inside and print, okay, percentage d, it will print the value of n 5 into I is changed now. Second percentage d, take the value of I, 5 into 2, it will print the equal, and as well as percentage d is n star I. Then what is mean 5 into 2 equal to 10. Okay, 5 into 2 equal to 10. Likewise, okay, then it I plus plus 5 will get incremented, and 3 less than or equal to 10, then it will print 5 into 3 equal to 15. Likewise, it will go up to 5 when n value is become 10. Okay, 10 less than or equal to 10 equal to true 5, and percentage d, it will take the I value 10. Okay, equal to, okay, up to this it will go, okay, equal to 5 into 10 equal to 50. Okay, this is the way our logic is working. Okay, for example, we'll run the program and see the result. So I'm asking an integer, I'm giving it as a 5. I will get a multiplication table. So the integer is given as a 5. The multiplication table 5 star 1 equal to 5 to 5 into 2 equal to 10 up to 5 into 10 equal to 50 is printed. For example, I want it up to 16. We will increment here. Okay, we will increment here. Okay, 60. If increment 16 means what will happen? It will go up to the term 16. For example, 5. So it will go up to 16. 5 into 1, okay, 5 table, multiplication table, okay, up to 16. It will go like this. So I want a table of 12. So I give enter 12. What it will go? It will print the multiplication table of the 12. Okay, and multiplication up to 16. Okay, that's it for the for loop. That's it for this video. Next video we'll discuss about the nested for loop. Okay, that's it. Thanks for watching it.